Here we go with a little bit of homework help, Unit 5, Lesson 7. In these first problems, we're supposed to connect this table with this equation right here. And so we want to be comparing the function of the table compared to the function of b is equal to 4 times a minus 5. And then I have various questions that I need to be able to answer with that. The first one asks, when a is negative 3, is b greater or is c greater? So when a is negative 3, c is negative 20. So with this one over here, c is equal to negative 20. And then when over here, when a is negative 3, I have 4 times negative 3 minus 5. And b is equal to negative 12 minus 5, which makes b equal to negative 17. And then when I compare these two, negative 20 to negative 17, I have to remember that on a number line, negative 17 is closer to 0 than it is to, or the negative 20 is closer to 0. That makes negative 17 the answer for which one is greater. So that means b is my greater value. In part B, when c is 21, okay, let's get rid of some of this information here. When c is 21, what is the value of a? Well, since there's no c in my equation, b equals 4 times a plus minus 5, I don't have to worry about that one. I just simply have to read my table. When c is 21, a is equal to 5, but I don't think you're supposed to put a equals, just put 5 in there, I believe is what it's after. Put a equals 5, I'd be much happier with that. Part C, it says, what is the value of b that goes into this value? Well, now that we're talking about the value of b that goes into the value, then I have to figure out if a right here, so a is still equal to 5. To figure out b, I just need to simply use substitution. B would be equal to 4 times 5 minus 5. 4 times 5 is 20, and 20 minus 5 is 15. So the value of b that goes into it, b would be equal to 15. Let's go on to letter D. Letter D says, when a is 6, is b or c greater? When I look back at my information, I don't have a 6 in this table. And what I would have to do is figure out, is this linear or not? And I can do that just by checking a couple of different things. I can check to see the change in x is going to be increasing by 3 here and by 27 here. And the change in y, that gives me 27 divided by 3, so that makes my slope equal to 9 between those points. 2 to 5 is 3 units of increase. 3 to 21 is 18 units of increase. That makes my slope equal to 6, and that tells me right now that this is not a linear function, whereas the other one is a linear function. And since we're comparing linear to nonlinear, figuring out what the output is when the input is 6 will be very difficult to do. We could do that with a lot of reasoning and a lot of logic, but for this case right now, knowing that it's not going to be very easy to find, there's really not quite enough information to be able to solve this one. For part E, it says, for what values of A do we know that C is greater than B? So all the values of A, what values of A do we know where C is greater than B? In this case, you're going to have to actually do some comparison, and you're going to have to use some substitution and solving each of these ones out. So when we talk about these pieces, you're going to have to take your equation, and you're going to have to compare all the way through where we see these values come out. So when we talk about this table, for this table, it's A and C. What I think would be a good thing to do would be able to be comparing when A is the same thing. We can add to our function table here, and we can look at what happens when the value of B is given under these circumstances. So we found out the first one is already negative 17, where it's greater. When A is 0, that would make that 4 times 0 minus 5, which would make this one minus 5. Not very easy to see. I'm sorry, it's kind of small, but you get the idea. You'll need to go through each of these, and you'll need to simplify each one to find out which values will actually come out to a value that's going to be greater or less, equal, whatever. In this case, 4 times 2 is 8. 8 minus 5 is 3. And we see that both C and B are equal. Continue going through there so that you can answer the question, for what values of A do we know C is greater than B? And then give the smallest value. So I only want to know the smallest one. And then which values of A are greater than the value of B, or which values of A make C greater than B, and give me the largest value. So one number here, one number here. The next question, part A, match the function rule with the value that could not be a possible input for that function. When we talk about could not work, what we're looking at is writing a function rule, in this case 3 divided by the input. And then we're going to compare each of these. So we could have 3 divided by 3, 3 divided by 4, 3 divided by -4, 3 divided by 0, 3 divided by 1. And what I want to do is go through each of these and say which one of them would work. This equals 1, that one's good. This one's 3/4, that one's good. -3/4, undefined, and then 3. Of all of these, I would have to say that this one would be the one that could not be a possible input for that function because it comes out with an undefined outcome. Part B says to add 4 to the input, then divide that value into 3. So when we're talking about this value, dividing that value into 3, actually I think dividing into 3, I think would actually mean something like this, where we take that value and go dividing that value into 3. And so when we take that in there, we had to take into consideration this, where we see 3 divided by 3 plus 4, that's 3/7. 3 divided by 4 plus 4, that's 3/8. 3 divided by -4 plus 4, that one's 3 divided by 0. I think I just found the problem right there. That one will be undefined as well. Looking at the next one would be 3/5. So that's there. Letter C, it says subtract 3 from the input and then divide this value into 1. So with this one, what we're looking at would be 1 divided by 3 minus 3, which equals 1/0. And I think we already found the one that's not going to work right here because that comes out with an undefined. I just want to make for sure though, if this one right here is 4, that would make this 1/1. If it's -4, it would be 1/7. If it's 0, that would be 1/-3, and then 1/-2. It definitely would be that first one. I think it's a little tricky in the wording, especially when we see something about dividing into, and that into means that we have a numerator of that value. One more problem. We're going to skip this one, go to this last one. This one is kind of a big one. I don't really have any kind of concerns about how y'all are solving your equations. You're doing a great job. I'm going to go ahead and do this equation. I'm going to solve it up here. Negative, or the opposite value of -2 times x plus 1, close the parentheses, is equal to 9 minus 14 times x. Our first step should be to use the distributive property. And we'll go ahead and recognize that this negative sign here at the beginning can also mean the opposite value of. Anytime we multiply by a negative, our positives become negatives and our negatives become positives, so they become opposites. So the opposite value of a -2x would be a +2x. And the opposite of a +1 would be a -1, which would then give us the rest of the equation. And then we use the properties of equality to simplify, or to start solving for x, or getting x all by itself. Adding 14 times x to the right means adding 14 times x to the left to get 16 times x minus 1 is equal to 9. I would add the constant 1 to both expressions. To get rid of the 1, I have 16 times x is equal to 10. I divide by 16. Divide by 16, and x equals 10/16. But I want to simplify this because it can be reduced. They both have a common factor of 2, which means x would the numerator would reduce to 5, the denominator would reduce to 8, and this is the solution that you would need to put in right here. Please do not change that to a decimal. I don't want a decimal. Please leave it as a fraction. It's totally okay. Part B is the spot where I really have big concerns. And the reason for that is because when you explain your reasoning and checking that your answer is correct, I see a lot of people just referring back to their work. They're saying that this is how you check your answer and that's how you know you're correct. The problem is, what if this answer is wrong? What if it's not correct? If it's not correct and you're claiming that this work proves or is reasoning that you're correct, then your reasoning is incorrect. And then not only did you miss part A, but then you also missed part B. What I need from you is I need you to change your understanding of this explanation piece. I am making a claim that X is equal to 5/8. I have no evidence that proves that X is 5/8. And the only way that I can prove that or have any evidence of that is not with all this work. This doesn't prove that I am correct. Okay? This is just my assertion, or this is just my claim that this is the answer. Instead, what I have to do is I have to use substitution. In that substitution, I still have the negative sign, the -2, the 1, the 9, the minus, and the 14. What I have to get changed here is I'm making a claim that X is 5/8, and so anywhere that I see 5/8, I need to substitute that value in to the original equation. And you'll notice that I'm not trying to solve for X. I am simply substituting to see if I am right. So starting within the order, or within the parentheses first, following the order of operations, I'm going to take my value and I'm going to do -2 times 5/8, which gives me -10/8 plus 1, which would be more eighths. We can change that 1 and consider that 1 as 8/8. And so what I get in here is -18/8. And I'd be taking the opposite of that. The opposite of -18/8 is +18/8, but 18/8 can be reduced to 9/4, and it would be the positive. Now, if I'm right, then the stuff over here on the right side has to also come out to 9/4. That means that I would need to take 9 minus 14 times 5/8, and that 14 times 5/8, I'm thinking here, 14 times 5 is 70, so that would be 70/8. And then my 9 minus 78, something to equal 9, and I'm talking about eighths, would be 72/8 is equal to minus 70/8 gives me 2/8. Now, I know what you're thinking, Mr. Quilter, you made a mistake. Yep, and I hope you caught it. And what I want you to do instead is I want you to go back and I want you to fix it. I want you to figure out where I got this wrong and why I got it wrong. Right now, based on the work that I did, this is a false statement. And since that's a false statement, that would suggest that X equals 5/8 is the wrong answer. So the question is, did I get the wrong answer when I solved for 5/8, or did I get the wrong answer when I checked the 5/8? What I want you to do is use a calculator first and check to see if my 5/8 is incorrect. If it's incorrect again under the calculator, check it again, and then I want you to go back and I want you to try and solve that equation again. The big thing with this is right here, I don't want to see your work again for how you solve for X in part B. You need to show me how to check that your answer is correct, to confirm that your answer is correct. Okay, I hope that's enough for you. I hope that makes sense to you. I'm not upset with you. I really need you to understand how to answer that kind of question. It's all through substitution. Let me know if you need more from there, more from me. I'm happy to help. Take care.